I like to find like f of 0 and
Yes, a small examples
f of,
means f of 0.
was is this the one from this year? It is, right?
Yes,
Yeah.
problem 5 of this year. For example, x0, x plus minus 1, y0, okay? These things. One part is a special case. For example, x is equal to y, x squared is equal to y. Something like these things. X is equal to negative y. Okay, it depends on the. For example, if you replace y with x squared, then we have f of 0, right?
Mm-hmm.
One idea is get rid of complicated term. Means what? For example, if we write it for xy1, then xy2, then we can cancel this by subtracting, right?
Mm-hmm.
Sometimes you should write division. Sometimes you should check that f is 1 to 1 or not. Sometimes this part useful. Then sometimes, for example, you should consider f of 1 is a constant and calculate all things in terms of c. And the other one at the end, check the answer you found for f and write in your answer sheet for function. At the end, you should check the thing you reached, okay? It is important. If you don't write, we'll subtract mark. Okay, these things. There are also more approaches I will tell you. So and here we have real numbers. For example, if you have positive real numbers, we cannot check 0, okay? If, for example, f
Okay.
is from positive real, because here is f is from R to R, we can check above 0 to 0. Okay, so try to see what can you reach for this problem, okay?
Yeah. Should just do what I did in the test. Yeah, okay. Okay, so I end up just like kind of getting that f of 0 equals 0 and that f of a equals f of negative a.
Yes. Can you explain how?
So first I plugged in x equals 1 and y equals 0.
X equal 1 and y 0.
So I get f of 1 equals f of 1 plus f of 0.
Yes.
And then I plug in x equals 1 and y equals 1 half. I get f of 1 half plus f of 1 equals f of 1 plus f of 1 half.
Then you
And
can
so
cancel
combining,
this because these two are equal, then f of 0 is 0, right?
yeah,
Good job. Also, for example, for this one, we can say, okay, if you replace x with y with 0, we can conclude f of 0 is equal to f of 0 plus f of 0, right? So we
yeah.
can
So
conclude
f of
f
0 is
of 0
0.
is 0, right?
Yes.
But if when you reach this one is obvious. But let's write our results too. If x is 0, so you can conclude f of negative y plus 2y f of 0, right? Is
Yeah.
equal to f of 0 plus f of y. You know
So
f
yeah, f
of
of
0 is
negative.
0, right?
Yeah. So it's all 0. Okay.
Yes, so we reached that f of negative y plus 2y f of 0 is equal to f of y. If we didn't have this, so because you reach this from here, we can conclude, for example, f of negative y is f of y, right?
Mm-hmm.
And because you reach this, we don't need to call it 2, because from this one, we can reach this one. It's not a new result. So second one is this, right?
Mm-hmm.
You only prove these two things, right?
Yep.
Okay, now we checked x is 0. Now we should check what is 0.
Y is 0. Right?
Yes. Then we can conclude f of x squared is equal to f of x plus f of 0, which is 0. So third result, okay?
Yeah.
So we don't know which of them useful, which of them not, but you should write anything that maybe can be useful. For example, maybe we reach 10 results, but 6 of them are useful, okay? In the beginning,
Yeah.
we don't know, so try to reach anything, write down anything that may be useful and number them. So here we consider this one now because we know f of 0 is 0. If we want to reach if we want to use f of 0, 0 for this one, we should consider y is equal to what?
Y equals x squared.
Y is equal to x squared. So, and also we know f of x squared. So here it would be f of 0 plus 2x squared f of x is equal to f of x plus f of x squared, right?
Yes.
This one is 0. F of x is also f of x squared, right? So we found a relationship. F of x squared is what? Is equal to f of x. Also is equal to what here?
X squared f of x.
Yes, we can cancel 2x squared of x. Okay.
Yeah.
So we reach fourth result, right?
Yeah.
And also we reached f of negative x is equal to that. So here, what we found that f of x here, f of negative x is equal to f of x, right?
Yes.
In second result. So let's do something. For example, here, I told you you can write it for xy1, xy2, for example, to get rid of this, right? Something like that.
Yeah.
And
Yeah.
also, let's do something. Do you agree we can write it as this? F of x squared minus y plus 2y f of x. Instead of f of x, we can write what?
X squared fx.
Plus this, right?
Mm-hmm.
So, what can we do for this one?
I'm not sure.
So, we know f of something is what, right?
Mm-hmm.
When we know f of something, for example, if we write 3f of x, we can say it is equal to what?
It's x squared. Okay, this becomes f of fx squared, which is
You pay attention to fourth result, how can we write it in terms of f of x?
equals f of x to the 4.
If you are using this equation, this one,
Oh, no, I'm using the first one.
this one.
F of x. Yeah.
Okay, so let's write this one, for example, as a star. This one as double star. By using a star, you can say it is equal to this one whole squared. So f of x whole squared, right?
Yes.
Okay.
Wait.
What else? Can we use double star to simplify this?
Wait, isn't it? Isn't
It's f of this whole squared, right?
f of x squared?
This one, right?
Why is a square on the outside?
Because it is f of this inside the squared, right? So f of this inside the squared. What's the problem?
I'm turning f of x into f of x squared.
I applied for this. I applied for this part. F of this part But you said you want to apply for this one, right?
Yeah, the inside.
So we can say also it is equal to f of x squared,
X
right?
squared.
So we can conclude
Which if
these
I
two things are equal, right?
yeah, but then the inside it becomes then I can turn this into f of x to the 4, right?
Which one? This one?
Yeah, I turned that into well, because it's the same thing as the middle term on the number 4. Wait, can you do that?
So you said
You can't,
f
right?
of x squared. We can
You can
use
do that, right?
this one, right? We can use double
Yeah,
star. So inside whole squared, so x to the 4, right?
yeah.
Times f of what?
F of x squared.
Yes. Again, we can use f of x squared, right? X squared f of x, so it would be what?
Equals x has 6 f of x.
Exactly. Now here we can calculate this in different approaches. For example, we can use this. If we can use double star, this one, in the beginning, then we can say what?
Uh,
We want to use double star
x
in the beginning
x
from here.
squared. X squared.
No,
F of
f of x squared, right? Because we f of x here in terms of x. So you should replace x
yeah.
with f of x, right? Times
Okay.
f of x, right?
Yeah.
So f of x, again, we should use double star, right?
Yeah.
So it is f squared x, f of x, x squared f of x. So it would be x squared f of x cubed, right?
Yeah.
Now we can conclude what is equal to what?
Conclude what is equal to what? X squared f of x squared f cubed of x equals x to the 6 fx.
Yes.
So f squared x equals x to the 4.
But we can divide
So
by that under what condition?
fx not equal to 0.
Yes.
So
So
fx equals 0 is one case.
but we can say something. The agreement x is 0. So if x is not
Or
0,
not.
if x is not 0, you can say f cubed of x is equal to x to the 4 times f of x, right?
Yeah.
Do you agree if x is 0, this equation also is correct because 0 is equal to 0 because f of 0 is 0, right?
Yeah.
So
Yeah.
we can say this one is always correct. F cubed x is equal to x to the 4 times f of x, right?
Yeah.
Okay. Now we want to divide both sides by what?
fx.
Exactly. Under the condition that it is not 0, right? If
Yeah.
f of x is not 0, then you can say f of x squared is equal to what?
Is equal to x to the 4.
Mm-hmm. Okay. So we reach this value, right?
Yep.
So we can say f of x is what or what? Or what?
X squared negative x squared and 0.
Exactly. It can be x squared or negative x squared or 0, right?
Yeah.
Okay, do you agree f of 0 satisfies all of them? Because 0 squared is 0, negative 0 squared 0, 0, 0, right?
Yeah.
Now, we should consider two cases. For example, suppose two values that are not 0. Is it possible to have, for example, for some x's, we have this one and this one? You should reject this. You should say, for example, if for one non-zero value f of x is x squared, for all non-zero values f of x should be x squared. So we can have only this, or only this. Okay?
What's the
For this part, want hint or want to try on your own?
Wait, what am I trying to prove?
Look, I said, for example, for 0 it's not important. As I said, 0 satisfies all of them, right?
Yeah.
Suppose if x1 is not 0, okay?
Yeah.
And f of x1 is, for example, x1 squared. We want to prove that for all non-zero values, f of x is x squared. Okay? Then you should prove why for all x, f of x is x squared. It is our claim. Okay? You can check. You can check, for example, is it possible, or if you want, you can also consider like this. Because for each x we have this, you can consider this. Suppose x1, x2 are not 0. And is it possible to have, for example, this one and this one? Suppose f of 2 is negative x2 squared, okay? One case is this, if you have these two cases. Let me write cases. First case, x1, x2 are not 0. F of, for example, x1 is x1 squared. F of x2 is 0, okay? Let's consider this one as first case because it's easier. Work with 0 is easier. Second case, x1, x2 are not 0. F of x1 is negative x1 squared. F of x2 is 0. Third case is this. If we reach one contradiction for each of them, then we can say f of x is always x squared or negative x squared or 0, right?
Wait, so what's... I'm kind of confused. What is f of x2 equals 0? Wouldn't that have to be 0?
Can you say it again? What's the problem?
How, if x2 is not equal to 0, how does f of x2 equal 0?
Because here we proved f of x is 0 or x squared or negative x squared here because we wanted to divide, right? We reached this result. We know f of 0 is 0, but maybe, for example, f of 4 is also 0, right?
If f of x is equal to 0 for all x.
Yes, we want to prove if f of, for example, 4 is 0, then f of 5, f of all of them equals 0, okay? And then it satisfies this function, right?
Okay.
We want to say it is not possible that f of 5, for example, is 0, f of 6 is equal to 6 squared. We can't have two of them, okay?
Yeah.
So we have three cases to check, 3 choose 2. So first and second case, because one of them is 0, it's easier to check to reach contradiction. Try to prove it's not possible that x1, x2 non-zero values, f of x1, x1 squared, f of x2 0. Use this equation and the thing we had and try to reject it, okay?
Okay. Okay, so I got, if I set x equals to x1, I set y equals to x2, then I get f of x1 squared, which is plus 2x2 times x1 squared.
Can you say it again? You replace x and y with what?
X equals x1, y equals x2.
Oh, okay, so f of x1 squared minus x2 plus 2x2 f of x1, right? Or you can say 2x to x1 squared, right?
Yeah.
Is equal to f of x1 squared plus f of x2, which is 0, right?
Yeah.
Then what?
Then it's oh wait, it's minus x2. Oh wait. Well, it becomes x to the 1, x to the 1. I can just square it then, right? Wait, okay, no, I didn't account for the x2 part. I'm not sure right now.
Okay, so here we have two f's are left, right?
Yeah.
Okay, but we prefer to write in a way that, for example, at most one f left, right? If we
Yeah.
can determine them, then one f will be left, it will be better. Do you agree if instead of, because look here, it was f of x, that was the reason that this f was left, right? So if this one is 0, f of this one is 0, it would be better because we know f of 0 is 0, right?
Mm-hmm.
So it's better to replace x with what, y with what?
X with um
We want that f
0.
of x be 0.
Yeah. So X should be 0.
X
Or
or
X
x2
equals
to
X
use
equals
this. Y
2.
x1, right?
Yeah.
Then it would be
Yeah.
y f of x2 squared minus x1 plus f of x is 0, so f of this one also 0. F of y is f of x1. F of x1 is x1 squared, right?
Yeah.
Now it is better because we have only one f. And we proved f of this is what or what? Or what?
0 or squared or negative squared.
Yes, or x2 minus x1 whole squared or negative of this, right?
Yeah.
Is 0 possible or not?
0, no, not possible because
Why
that's
not?
x1 squared.
Exactly.
X1 is a positive
x1 we said
number.
is not 0. Now
Yeah.
let's check this one. x1 squared is equal to x2 to the 4 plus x1 squared minus 2x2 squared x1, right?
Yeah.
Now here we can cancel 0 is equal to x2 squared minus 2x1, right?
Yeah.
We know x2 is not 0, so we can conclude x1 is x2 squared over 2, right?
Yeah.
Now if we check last one, if x1 squared is equal to negative of that, so it would be negative x2 to the 4, negative x1 squared plus 2x2 squared x1, right?
Yeah.
So here, what can we say? Let me um, do this. Okay. From here, what can we conclude? We can say 2x1 squared, right? Plus x2 to the
Mm-hmm.
4 minus 2x2 squared x1 is 0, right?
Mm-hmm.
Oh, so no. You don't need to expand this. We can write this one as negative x2 squared minus x1 squared. Because it's negative, we can take it to left hand side. So because sum of these two squares equal to 0, then we can conclude what?
We can conclude. Well, this is a contradiction because
They are at
maybe.
least 0. When some of them is 0, each of
Yeah.
them should be 0. x1 0 contradiction,
Yeah.
right?
Yeah.
So we reach only this case, right?
Yes.
Okay. Now here we have only this case. So if we replace x2 was good. Again, we replace x with x2, okay?
Mm-hmm.
Mm, if we replace, for example, y, do you agree we proved you proved in the beginning f of negative x is f of x?
Mm-hmm.
So in previous case, y was x1. Instead of x1, we can write what?
Y equals negative x1.
Yes. Then again, this part 0, we can cancel, and we can write again. Then again, we have one f of x2 squared plus x1 is equal to f of negative x1, which is equal to f of x1, which is x1 squared, right?
Yeah.
And we know it is equal to what or what or what? F of
of
this.
is this gonna be x squared, x2 squared plus x1 squared,
Whole
or
squared
negative of that?
or negative. We can cancel negative of that because you can take it to left hand side, sum of 2 squares 0, and then that one 0, right? We can cancel these two things quick, right?
Yeah.
So we need to only check this, x to the 4 plus x1 squared plus 2x1 x2 squared, right?
Yeah.
So we can cancel x1 squared, so 0 is equal to x2 squared is equal to x2 squared plus 2x1, right?
Yeah.
So here we can conclude x1 is negative x2 squared over 2, right?
Mm-hmm.
Here we proved x1 is x2 squared over 2 negative. That's contradiction, right? Because if we
Mm-hmm.
call, for example, this one, let me see how many results did we have. 4. If we consider this one as fifth result, if we combine these, suppose this one plus this one, 2x1 is 0, right? So x1 is 0 and that's a
Yeah.
contradiction. Okay. So we prove first case is not possible, right?
Yeah.
As how many homework did I tell you today? I think no homework, right?
Mm-hmm.
Okay, as homework 1, try the rest of this, okay?
Okay.
Now let me tell you some problems related to functions. And before that, let me tell you around the things that can be useful. Small examples, special cases, get rid of complicated term. I told you sometimes, for example, f of 1 a constant, consider other terms. Sometimes you should find a fixed point. Fixed point means a point that f of x is x. Sometimes you should check is it 1 to 1 or not. Because if it is 1 to 1, if f of something is equal to f of something, you can cancel f's. Do you know this or not?
No.
If f is 1 to 1, do you agree if f of a is equal to f of b, we can conclude a is b?
Yeah, I guess. Yeah,
So it means,
extension.
means that you can cancel f's, right?
Yeah.
Sometimes also this idea useful, you should create an equation and variables, okay? And then find f of x. I will tell you similar problems. Sometimes, for example, you have something like this, you should calculate f of x. Sometimes you should check some examples to see do they work or not. For example, check f of x, x works, f of x a constant works or not. Sometimes you should change f of x to k f of x. I will tell you in problems they are what.